Hello, everyone. Thanks for being here today. This is a presentation for the Urban Camp Program, which is a partnership between the USDA Northeast Climate Hub and Cornell University, our Harvest New York program, and our Climate Smart Farming program. And today we have two of our co-leaders here and one of our urban farmers here. So, Kristen, would you introduce yourself?
Sure. My name is Kristen Benson. I have a fellowship with the USDA Northeast Climate Hub, and I've been working on a few projects, mostly focusing on climate adaptation and mitigation.
Great. Yolanda.
Hi everyone, my name is Yolanda Gonzalez. I'm an urban ag specialist with the Harvest New York Urban Ag team and helping lead this urban camp program.
And then Rona.
Hi, my name is Rona Taylor. I'm the executive director of the Central by Southeast Brooklyn CDC, which serves Flatbush, East Flatbush, and NRC, also now Ocean Hill, parts of Crown Heights. And I was part of the Urban Camp and Land Steward program.
Excellent. Okay, so I'll just take a minute to introduce myself. I've been a part of the Urban Camp program for the past year, working with Yolanda, Savannah, and Kristen Bunsen. And I'm based in Ithaca, New York, where I have a couple of roles for the College of Ag and Life Sciences. I lead our urban camp and dairy camp programs with the USDA Northeast Climate Hub. I helped develop the Cornell Climate Smart Farming program and tools many years ago, and we're actually going to be updating the website very soon. So look out for that switch, which should be great. And more recently, I am grant funded. Most of my funding now comes from a new institute at Cornell called AI Leaf, and that is the AI Institute for Land, Economy, Agriculture, and Forestry. And I'll talk a little bit more about that. So that is why I'm really excited to talk to you today about strategies for adaptation and mitigation in light of climate impacts and how we can use AI for agriculture. But I'm also going to talk about the climate smart farming decision tools, which are a type of digital decision tool. And I'm also going to talk about digital agriculture because a lot of what we do with AI is based on digital agriculture tools. All right, thank you. Next slide. Okay, so today I'm just going to give you a really brief context for climate impacts and adaptation. We have recordings of our past webinars up on the Climate Smart Farming website, and this recording will be posted there too. I'm going to talk about using digital technologies to support resilient food systems, give you a brief overview of the climate smart farming tools and how you can use them in urban settings like New York City. And then I'm going to switch to look at some more in-depth digital ag applications for urban farms, and then progress to machine learning and generative AI in agriculture, and then some opportunities and challenges. So ask me any questions or interrupt me, Rona, and our team if you have questions. Okay, so as we talked about last time, we know that with climate change, especially in New York City and urban settings, there are many challenges that we're already facing and we're going to increasingly face, including extreme rainfall, which can cause flooding of our urban farms and erosion. For farms that are near the Hudson River or Long Island Sound, we can see saltwater intrusion. We can also see short-term drought. I didn't add this here, but along with high temperatures, we can see heavy wind events, higher temperatures, which can cause heat stress for poultry on urban farms or goats, also for crops and definitely for farm workers. We see new pests and disease and really challenging increasing variability and uncertainty. As we talked about, though, there are opportunities with climate change in general in the Northeast when we think about other parts of the country. We do have adequate water supplies in our region, and with irrigation on urban farms, water may become more expensive, but we should have access to it. We are also seeing longer, warmer growing seasons where we might be able to grow into November, longer seasons. We see shifts in productivity elsewhere, which means there's a large potential to expand and diversify markets. And this can create really great sustainable jobs and economic growth and get people and youth out on farms and have them more connected to the land. So, thinking about the impacts of climate change, how do we respond to these increasing impacts? So, we talked about the process of adaptation, which is adjusting to actual or expected climate changes and its effects. In human systems, adaptation seeks to moderate harm or exploit beneficial opportunities, take advantage of them. In natural systems, human intervention may facilitate adjustments to expected climate and its effects. That's just saying that if we can adapt, it may help us be better adjusted to climate impacts. So I want to point out that there is a really great case study that was part of the New York State Climate Impacts Assessment. So if you would like more detail on how the climate is already changing and how it will change in the future, you can check the link there, newyorkstateclimateimpacts.org. And there's a really great case study. There were case studies all around New York State, but this one was conducted with Brooklyn Grange, really talking about how they are adapting to climate change. And so, one thing that we are working with our farmers and advisors on is starting to do adaptation and mitigation planning on urban farms. And this first step here is risk assessment. And how do we assess risks? We want to gather as much accurate information as we can. And one way to do that is to use some decision tools that I'm going to show you. The other is by implementing adaptation practices, and that may involve putting in place new technologies that can help the farm be more resilient, use less water, monitor soil conditions. And so that's where digital ag and AI can come in. So what tools do farms have to make better decisions, to increase efficiency and reduce risks, or get, use better information? So I probably mentioned these tools before, but I always like to make sure people are aware of them. They are free to use, and I've been going out and doing more talks lately, and I'm just always surprised to hear of really incredible ag advisors around the state that are using these tools on a regular basis. So if you haven't checked them out, please do. What they do is they take weather data from our Northeast Regional Climate Center, which is gridded to a 4 by 4 kilometer space around the address that you will enter. And they also include data from National Weather Service forecasts and incorporate agricultural models into the tools. And then there's some aspects of farmer input. So, for example, if you were to use the tool Rona, you would enter your address. It can be any farm location from Maine down to West Virginia. And then you would enter some of the tools, you enter some details like the planting date, the crop you're growing, and etc. So let's dig in. I'll show you. This is the first thing you'll see, and you can choose among several tools. The one that I hear people using most often is our growing degree day calculator. And there's probably other calculators out there, or actually paper copies of growing degree day calculations This one is especially powerful because it's updated on a daily basis. And so right now, I just chose this today because we're not in the growing season yet for 2026. The new tool will kick off probably around March 15th, even though most farmers may not be planting until May 15th, give or take. So what I did is for the planting date, I put in 2025. And so what it's doing, I also put the location of Governor's Island. It's actually showing me what was the growing degree accumulation for the entire season, across the season for 2025 at the location of Governor's Island. And you can see a couple things that are really interesting. First of all, I put in the growing degree day base of 50 degrees Fahrenheit, and that's a general baseline for growing corn. There are other options you can choose. And you can also put in a target for when that crop you're growing is going to be ready. When it's ready to harvest is based often on how much accumulation of heat the crop has had. So you can put it in and see when the crop will be ready to harvest. You can also put in last and first frost days, which is incredible because even anywhere on our urban farms in New York City, they can enter their address and the growing season and see on average every single day when was the first frost day and the earliest and the latest in the spring. And that's really useful information. So you can see here that the green line shows the season to date for 2025. The blue line would have been the 15-year average. The purple line would have been the 30-year average, basically. And the gray bars are every point of data that we have for that location over the past 50 years. And you can see that this growing year, the accumulations were higher, right around the 15-year average, higher than in some point there in September or in the July, it was above the 15-year average. That's just an indication that this was a much warmer, higher temperature season. And if you were to go back year by year by year, you would see that these seasons are getting warmer. So it's an indication of climate changing. The other great tool is a water deficit calculator. And you can use this, particularly in New York City, if you're irrigating. You would just enter the date of the last irrigation. And what this tool does is it tells you what type of soil you have. So you want to pick something about what you have, a similar crop to what you're growing. And again, because we're not in the season yet, I just chose 2025. So this is showing for the entire season of 2025, what were the rain events on Governor's Island? And if we were growing a grass crop, there were quite a few days when there were a lot of rain events, but they were small events. Every little dot is a rain event. The yellow events are yellow is when there's probably going to be plant stress. Orange area is where there's plant stress likely. This is here. And then red, if I can get down there with my pointer. How do I get down there? There we go. Red would be severe plant stress. So there were a couple days in August, July, September when there was likely severe plant stress. So a farm can monitor this on a daily basis if they want, because this is incorporating the forecast as well. So it will tell you what's the forecasted rainfall and if that is going to be enough to bring the farm soils out of plant deficit. So a really great tool. The other tool that's kind of just more for information, for really good context, is this visualizing climate change in the Northeast tool. And what this does, you can choose your county, any county in the Northeast. I chose Kings County, New York, and I chose the button for average temperature. So this is just going to show you what have average temperatures been over the period from 1951 to 2023. And the significant lines means that there's been a significant increase in average temperature by about 0.5 degrees Fahrenheit per decade. Significant means it is statistically significant. And this is again just showing you how our climate is changing, our temperatures are increasing. So that's a little introduction to climate smart farming tools. And they are one type of digital agriculture. So I want to move on now and touch on just giving you a general introduction to digital agriculture. Many of you may be using digital ag tools already, but it's good to have an overview of the scope. So digital agriculture is a data-driven management system where the traits of plants, soil, and environment are recorded with digital sensors and processed with computers or similar devices that are able to deal with data, a lot of data, to deliver information so that farmers can make decisions about that system. On a farm using digital technologies, they may be optimizing based on that data to optimize for production, for efficiency, like water efficiency, or sustainability to increase their efficiency. And they can choose the decisions that they're interested in. And this can benefit the farm itself, the environment, because if we use less water, use less fertilizer on farms, and that's multiplied, it's a benefit for the environment and the ag system. So just another way of saying this, it's using digital technologies to collect, analyze, and apply farm data. It often involves sensors on farms, innovation of things, devices, artificial intelligence, robotics. We often have robotic devices moving across the farm, or on larger farms, we see drones that are managed by a person controlling the drone that can look for weeds, that can apply fertilizers on a very, very precise manner. It can also enable real-time monitoring of soils, crops, weather, and infrastructure, like water infrastructure, and it can support data-driven decisions to improve efficiency. So I want to point out that we do have a Cornell Center for Digital Agriculture called CEDA, and they have a lot of great information. They also host a lot of webinars, Zoom meetings that are available. And so if you're interested, there's a great set of researchers working with CEDA, and they may be interested in like using your farm for some on-farm research. So it's great to be aware of them. And so I want to give you some examples of how digital agriculture can be used on urban farms, and probably is already being used on many farms in New York City. So, and why is this important? Well, urban farms, we know they're operating in small spaces with a lot of variable conditions. They're very much affected by wind, by rainfall, by high temperatures. Temperatures can often be much, much higher in an urban setting. And so digital monitoring can help maximize productivity per square foot of space. It's really important for these farms to be as productive as possible to earn a sustainable income. And so some of these tools, there may be an initial investment for the technology, but then they can help increase efficiency and yields and incomes. Automation can also help reduce labor or improve consistency across the farms. And then the data can help farmers adapt to climate variability. and weather extremes. So, some ways that we can use digital agriculture for climate resilience. We can use sensors to monitor for environmental conditions continuously. So rather than just going out on a weekly basis and looking at the soil, sensors could be monitoring that continuously. The data can support early detection of drought or heat stress or disease on a very particular measurement. So where I was showing you um, the water deficit calculator. That's a very accurate estimation based on models and based on weather and climate data, the climate smart farming tools. But if an urban farm has a sensor in the soil, that can be used to supplement the climate smart farming tools. It'll be even more particular to that farm. It can help automate irrigation and help reduce resource waste. And then increasingly, we see AI, predictive analytics can help farmers anticipate risks. So, just some examples. First of all, I guess Yolanda or Rona, do you know of some farms that are already using smart irrigation sensors?
Not in the city.
Really?
Yeah, me neither. This is so exciting because one of the things that I've been speaking with Yolanda about is just there are like 7 green thumb gardens in Ocean Hill. And one of the
Yeah.
things that I wanted to be able to do is exactly this, which is to do like an assessment to just yeah, to look at to assess the gardens for risk and to adapt mitigation and adaptation strategies,
Okay.
like as a pilot. So like this also, I was just voted in as the Brooklyn representative of the county committee for the USDA Farm Service Agency.
Oh my gosh,
And
that's great.
so I have an opportunity also to just share this with all the gardens and urban farms in Brooklyn. So this
Awesome.
is super exciting, and I can't wait to talk to you more about this.
Oh, great.
I
I
would say
wonder.
that also CEA facilities, so indoor hydroponics,
Uh,
aquaponics, they tend to have more of these sensors and automation happening rather
yes.
than the soil-based ones.
Yes,
Yeah.
I agree, Yolanda. Yeah, that's the next slide. Great. So, since soil sensors obviously can measure soil moisture and irrigation flows, they would deliver automated irrigation systems, delivering water only when it's needed, so it makes water use much more efficient. And that's something that's important. We talked about climate impacts to water. And as we get these heavy rainfall events, and then in between those, we have more drought, it's really important to more efficiently manage our water. It is a scarce resource, right? And if there's more drought between the heavy rainfall events, we need to manage our water more efficiently. So if we can irrigate only when needed or use soil sensors, that will be much more efficient. These sensors can collect data and send it back to dashboards like the image here of the phone, where the farmer can track water use, and it can improve water efficiency, especially on rooftop or container farms, or definitely controlled and environment agriculture systems. So this is an image of one of those systems where, and I think this is an example I found from Indonesia, where there's a vertical farm. Actually, Yolanda, what was the farm we visited where we had the reception?
Farm one.
Farm one in Brooklyn, right? I think.
Yes.
Yeah, super interesting. I wonder if we were to ask them what kind of sensors are they using, we would find out. It'd be great information. So sensors can monitor temperature, humidity, light, and carbon dioxide. They are automated systems, so they can adjust the lighting and the climate controls automatically as needed. And then it can help maintain a stable condition for year-round production. Really important. We can be increasing our productivity on more and more farms like this and have food grown increasingly in the place where it's needed. And that in itself is helping with climate mitigation. So this is an example of crop monitoring. So this image you see here is an automated crop monitoring robot sensor system. Maybe this is like cutting edge, more of a research technology, and potentially it would be used just on a part of the farm to give data. But these computer vision systems analyze plant images, and then machine learning is able to detect disease or nutrient stress, and it's able to feed that back to researchers who then use that data to build stronger and stronger models, and they can on farm hopefully develop these models to give early alerts to allow farmers to intervene quickly. These are the types of cutting edge research that our researchers at AI Leaf are working on. Another example is urban garden platforms, so low cost in the IoT stands for I just
I think
forgot
it's
it.
Internet of Things, right?
Thank you,
Uh-huh.
Yolanda.
No
Internet
problem.
of Things sensors, and that means they're connected throughout the whole system to connect to mobile apps, where again, farmers can monitor moisture, temperature, and light remotely, and then automation can trigger pumps or lighting systems. This is an example of Gotham Greens, which operates high-tech rooftop greenhouses in several cities, including New York City. It's using climate-controlled systems and environmental sensors, and then it's making data-driven management decisions to improve productivity. Another example is a farm case study of square roots. They're using indoor vertical farming and sensors and AI to monitor environmental conditions. This more precision management supports rapid crop cycles, right? So they're able to grow crops continuously. So now I want to just move on a little bit from here and think about we're hearing AI constantly now, and I bet you that all of us, even if we're not aware of it, are using it more and more. So how do we integrate AI into digital agriculture? So I want to mention how AI started. It actually was coined in 1955, which is a long time ago now, by John McCarthy, who organized a conference titled the Dartmouth Summer Research Project on Artificial Intelligence. Look, check out his computer there. It's amazing how far AI has come, but this beginning led to the creation of machine learning, deep learning, predictive analytics, and now prescriptive analytics. So I'll kind of talk you through some of those definitions in a minute. But artificial intelligence is increasingly a part of our everyday life. So just some examples. If you're getting recommendations on your YouTube page, even when you're searching on Google, often now, which is annoying, I think, the top of the search is an AI result of the search, even if you didn't want it. If we have increasingly self-driving cars in the city, in more rural settings, the bigger farms are using self-driving tractors. We can identify weeds on a cell phone using weed apps that are incorporating AI, and on and on and on. So I ask you to think about how many of these tools are you using. And so just to define artificial intelligence, AI enables computers and machines to simulate human intelligence and problem solving. It is based on statistics and probability as the backbone of what it's doing in the background. So it's AI is collecting a lot of data, and then it's using statistical models to make, to give the user the highest probability of an outcome, and then that's what it would report. That's a very simplified explanation. There are a couple of subsets of AI that are important to know. I think most people think of AI as generative AI, which is Chat GPT. And that is just one type of AI where it's creating new content. And I'll give a little bit more detail. Machine learning, on the other hand, analyzes data to make predictions. It enables a machine or system to learn from data and improve outcomes. So, generative AI, for example, it's systems that generate text, images, or recommendations. It's often based on large language models, and it can summarize, for example, for farm data. It can summarize farm data or produce management recommendations. It's always really important, though, to triple check the output that it gives you. And I think increasingly, if you use a tool like ChatGPT or others, when you ask it a question, you can ask it very particular prompts. It will provide an answer, but then you want to make sure, and you can even prompt it, please give me only data based on USDA recommendations, or please give me data from Cornell University. And then you can say, give me the citations. Please provide me the scientific citations for what the output you're providing. And that, I think, even in the last year has dramatically improved, but still you need to double check it. I think this kind of tool is really maybe useful for farm managers that have limited time and they know their system and they've been trained and they are trained in agriculture. So they may have a better sense if they ask a question that the output that they're getting is a little bit off or seems accurate. Or they can always contact Yolanda to back up the information. We never want to have AI take the place of agriculture advisors that really are trained and know systems and know production systems. But AI can be a tool to help Yolanda do her work more efficiently, or for farmers to do more of the mundane tasks. So machine learning is a subset where AI systems learn patterns from data. Again, it's used for prediction, classification, and pattern detection. So for example, we have researchers at Cornell that are agricultural economists. Ariel Ortiz Bobea is a great researcher at Cornell, and he's starting to do research. He's done a lot of great research looking at how climate change is impacting crop yields. And he uses large data sets like crop yield data from every county across the US. But now he can take that data and look at crop yield estimations with AI models and get an even more robust or accurate predictions. We have members of our team that are developing soil digital twins and using robotics. University of Minnesota is our partner, and they have a whole focus on improving robotics for disease detection. So I'll give you some examples of these. So just to summarize that part, machine learning analyzes data to make predictions, whereas generative AI creates new content or explanations. So one thing that, well, let me just introduce our institute really quick. This is what it stands for. So our researchers are working to combine AI with soil data, topography data, satellite data, working with ag scientists and economists to look at yield data or look at ecosystem trade-offs. Like, if a farmer is trying to make a decision about whether to change a cropping system or plant an entirely different crop to optimize water, if they had access to a model with really robust data that could compare these two options, that could help them make a better decision. We also have researchers looking at forestry and regenerative agriculture. And so we're really transforming the science of AI and decision support tools for climate smart practices. And we're trying to co-create solutions. So these are our researchers and our extension education team, which I'm part of down at the bottom there. So when we think about ChatGPT or generative AI, farms, Rona, you mentioned you could potentially work with your new initiative, and potentially there are some grant opportunities to demonstrate or be a pilot project for new technologies. Well, it takes time to develop a grant application, and often USDA or others will want farms to have a financial plan in place or a certified crop plan in place or a climate adaptation plan that we're working with you on. It would be great and really potentially possible if you enter some data into a generative AI tool, and it will help you draft some of that text that you can then check and double check. And it can help reduce the time maybe to apply for grants. Or reporting is very cumbersome and takes time. And AI could definitely help with reporting. It can help with farm marketing. If you want to start using social media more and you want to do a post every day about your urban farm, ask GPT to help you create or make the language more appealing, and it's amazing what it can do. So that is an opportunity to use AI that can really help farms. I'll just give you some examples. Some of these may be from more rural farms, but livestock counting or monitoring is increasingly going to use computer vision for detecting, counting, and monitoring ranch activities or livestock activities in real time. And this is a really fun example. This computer vision tool can actually, you can see all those sheep are a different color. It's in the past, it may have been a giant blob of sheep and it couldn't actually count each one, but it can, the sensors can actually differentiate. The AI system is differentiating what is actually a different sheep, and it's able to quickly count them. We talked a lot about earlier crop and soil monitoring. So AI systems can utilize data from sensors that detect their growth conditions and trigger automated adjustments to the environment. And then the AI part is it can connect to a model on a computer that's running that has the best options for that crop or that soil type. And it can work with the data from the farm to make the best decision. Similarly, when we think about disease and pests, I'll show you an example later of a regional scale tool, but these tools can very quickly identify pests and also scan images to find disease and detect it. And then it's able to do that because it has researchers have gathered like hundreds of thousands of pictures of mold or rot or insects on crops and then quantified and qualified those and entered the data, and now the computer systems can compare that. Another example is irrigation, and this is really important in urban settings. So by analyzing data, AI can identify patterns. Not just a system that can like turn on and off the irrigation system, but it could, if you had a system running year round and then the system notices that pump at that urban farm is, if the farm had 5 farms, that pump is all of a sudden using tons more water, it could help identify a leak. And so it's identifying patterns. It can monitor in real time and analyze data to help with early detection to prevent waste of water. Another example, this is an image of a drone that is doing very precise pesticide application. So it's able to target specific areas or like search the plants that have a problem and apply a very specific amount. And that's a great benefit for the environment if you think about the entire Northeast by reducing chemical use or reducing runoff to our streams. So, how AI could help mitigate or adapt to climate? It can help farmers, again, make the best decisions around cropping systems. If we know over the next 10 years, our seasons are going to be warmer and more dry, then it could help optimize the decisions a farm would make based on future climate models. It can increase the accuracy of soil measurement, and this is a new type of decision model that our researchers are really cutting edge working on, where it's not just using machine learning, but something called knowledge guided machine learning, where the scientists and the researchers and farmers are helping guide the huge amounts of data coming from the machines and make sure that it's accurate. And then it can help build observed and modeled data into farming decision tools. So what if we could take all the soil data or water data and build a even more accurate climate smart farming decision support tool? So these are our research goals, what we're working on. And I want to introduce you briefly to the deep soil tool, which is what's called a digital twin. And that means it's an actual model of all types of data that affect soil across the United States. And it combines coarse, medium, and precision remote sensing with high precision in situ, that means in the ground sensing, with knowledge guided machine learning to estimate soil moisture at various depths. So if you think about the soil tools you have available to you now from USDA, this is about 20 times more accurate and has a lot more data sources. So you can actually go check out this tool. It's at soiltwin.org. And the focus of really trying to develop this is we know that soils are incredibly important to provide nutrients for plants. They can help regulate soil moisture and they can help capture carbon in the soil and help adapt farms to runoff if we have really healthy soils. So managing our soils on a farm or across a region is really, really important. And if we have more accurate data, it can help us do that. So this tool can help with soil assessments on a regional scale, but also on a farm scale. So if you go to check out that tool, you can narrow down to your location. And then on the left-hand side bar of the tool, you can click on and off various data sources to see what's happening on your property. So this is currently integrating a lot of data sets. So Sergo is the tool I mentioned. That's the soil service digital tool, digital maps from USDA, but it also incorporates digital elevation maps. Yolanda, do you know what some of these are? Evapotranspiration data is heat evaporation data. GridMet is climate data. I'm not remembering what NLCD is,
Not ringing a bell.
but I could find that out I should know that if we're interested. Okay, so that was soiltwin.org and it's live now. You can go check it out. It is definitely incorporating AI. Another AI automation tool that researchers have developed at Minnesota is called deep learning based crop residue estimation. I love this name. I think we need to work with them to change the name because clod estimation seems like a really cloddy name, clumpy name. But in the image there, on the image on the left, is just an image of soil, and you can't really see the soil clumps. But knowing the aggregate type of soil is really important, right? Because if the amount of soil aggregation or whether it's really healthy soils or not, this can help estimate that. And you can see on the right hand version, this is using deep learning machine language models using hundreds of thousands of images of soil that have been captured. This is in the Midwest, and using machines to kind of draw images around each of those clots and differentiate them and measure them so that on an aggregate level, we know we have a really much stronger sense of soil health. And so this was done through arduous work of gathering I said 100,000 images. I was wrong. 15,000 images across 7 Minnesota counties, adding in where there's tile, looking at estimating runoff levels with very specific grid pointed data points, and then training the machines. And that means like giving them the data, looking at what the output was and improving it over time. And so this is an image that shows crop residue cover using satellite images from this model. And it can create much more accurate ground truth data. We can't go out to every single farm and look at their soil, but if we can use satellites, we can get a much better sense of what's happening. And then we can make better decisions or predictions about what's the precipitation runoff going to be, what's the slope losses, and that can affect watersheds. So this is definitely a research tool, but it could be expanded to be a very helpful tool for watershed management. So what we can do, what you can do as farmers is, I think the first step is to be interested in developing a greenhouse gas plan or adaptation plan for your farm, and then starting to think about what kind of data do you need to make better decisions, and then how can I use these tools to inform the decisions, but then try new things. So implement some changes in practices. Some of those changes may be I'm going to invest in soil monitors for my farm because then I'll be able to more accurately monitor the soil health, but also water use. And then I want to end by acknowledging there are a lot of governance and environmental concerns over AI use. And I do struggle with this myself because I'm trained in environmental policy and I teach about environmental law and policy, and I understand the environmental impacts of using AI for the climate are huge. And so I try to use AI sparingly. I try to use it when I need it. So AI can have a significant dual impact. Like it can have a positive impact on the climate in the ways that we talked about through reducing energy use or reducing water consumption. But AI can have a huge impact on energy requirements for producing that data and water for cooling the systems and the data systems. AI growth could add 22 million metric tons annually of CO2 and water. And we need to work to make sure that we're using this technology effectively. We're not overusing it, and we need to put policies in place. Other challenges are who owns the agricultural data collected by sensors, and farmers are very, very concerned about privacy, that their data is their data. So we need to make sure that we're not inaccurately sharing their data and that they have control on the data that's their data, and that they can make decisions based on that data. So there needs to be a lot of transparency in these systems. There's also equity and access challenges. These technologies can be costly, and they may exclude small farms, including many of our urban farms that are operating on really tight margins. Maybe this is an opportunity for grants, collective grants, to obtain some of this technology, or work with researchers at Cornell and have them do pilot projects. There can be definitely a digital divide between regions and farm size and also ages. We've talked to farmers that are on the older end of farming ages, and they are not interested necessarily in using computer systems. Younger farmers may be already using AI a lot or digital, and they're very interested. One thing to think about is if we want to get more youth out to farms and interested in farming, adding in technology that's really cool and can be interesting can help youth become interested in farming. But there's a huge need for training and capacity building, and that's something where we are trying with AI Leaf to do more training for extension and then farmers, and we need to build capacity. And then there needs to be public investment to make sure there's equal access. So just some key takeaways. The climate smart farming tools I showed you can provide more accurate information to farms in the Northeast. Digital agriculture is increasingly being used to integrate sensors, data, and using AI to help farms be more efficient, use their resources wisely. Urban farms can definitely benefit from monitoring and automation and reducing, maybe even using generative AI to reduce impacts on labor, reduce the workload for farms that need to fill out reports or apply for grants. And then machine learning is a different type of AI that's increasingly built into some of the tools and the models that you might not even be aware of, where it can help us analyze data. And then there are definitely issues with AI that we all need to acknowledge and be aware of, and push our agencies in our government to set more equitable and fair policies. All right. So thank you guys for your attention. And I guess I'll end by asking you, what is your experience or thoughts on using some of these tools? Anybody? Kristen, what are your thoughts?
I thought your comment about telling AI where to source its data from was really helpful. Um, in the vast world of AI with its ability to occasionally hallucinate. Um,
Yeah.
I think it's that's just a really helpful point to know that you can tailor where the AI model is getting its information from, just to make sure that you're getting things that are backed in not just the reality of somebody said them, but backed in like strong science. So I think that's a really good call. And
Yeah.
yeah,
Excellent.
that's cool.
Yeah. Yolanda.
Um,
Yolanda actually participated in one of our AI Leaf strategic planning sessions as
mhm,
a agricultural extension expert, and we wanted to have her there so that we could
mhm.
get input from people actually working with farmers. So
Yeah.
that was
I
helpful.
thought the soil measuring tools were important, and then also like the irrigation.
Mhm.
Um, yeah.
Okay.
So like checking for leaks and because like those things add up over time. So if there's a
Mm.
sensor way to check that's great.
Yeah. Rona, any thoughts or questions?
Yeah, I would just like to add to to what Yolanda is saying about the irrigation piece. That's like really critical. And I think it will really help, um, especially because like in the summertime, a lot of our members are traveling or they're not around. And so
Mm.
being able to know, like we're trying to develop a drip irrigation system,
Hmm.
right? And then if someone just needs to come like once a week or twice a week to like top off the whatever, if we're using buckets or whatever kind of whatever we end up deciding on,
Hmm.
um, there are some things that we can actually put in the soil that will release water slowly, etc., that
Yeah.
we have a sense of like when that needs to happen so that the plants aren't experiencing stress, especially like last summer it was really hot on a number of days. So
Yeah. Excellent.
yeah. But
Great.
yeah, I see tons of application for for these tools.
Great. It's interesting because I gave a talk for an organization, and there were about 10 dairy farmers in the room, and they were some of the biggest dairy farmers in Pennsylvania and New York. And they were on the older side of age, as is happening in the dairy industry often. And I asked the same question, and only one of them, who was on the younger side, was curious. But he
Hmm.
was also like, no way. I'm not gonna do this, because the
Really?
farmers that he works with, the farm laborers, aren't using the aren't using any tools, and they're not he doesn't think they'll be interested in being trained. So it was really interesting. On the other hand, I think they may not realize that a lot of the information and companies they're working with are increasingly using the AI and tools to help advise them.
Hmm.
Yeah. So, all right. Well, thank you so much for your attention. And that is my email and our Climate Smart Farming website. And let me know if you have any questions. Okay. Thanks.
Thank you.
Bye.
Let me know when you stop recording.
Hmm.